Good morning. In this lecture series, we see about projection of points. Last class, we see only the points in a first quadrant. Let's see each and every quadrant how to solve this kind of problem in a real-time example. Okay. So whenever you are pointing place that a quadrant of it's a front view and top view are brought in the same plane, the observer to see the clearly. The front view is a visible. It is a view on the vertical plane, but as a top view is a view on the HP plane is rotating in a downward 90-degree in a clockwise direction. The front part of the HP is come below XY line, and the part behind the VP is become above. The observer and note the process respective quadrant in respective quadrant. So we already last lecture series we see the a point A is located in a first quadrant. Similarly, we locate the point B, point A located at the second quadrant. Okay. So whenever observer is looking at the back side of the vertical plane, the location of the A dash and A for the that is a point A in the second quadrant. And similarly, the third quadrant we locate the point A, the front from the front and top view of the observer we locate in the third quadrant. So we are looking at the A dash. So what is the similar cases we discussing about the fourth quadrant A dash in for the below A dash. Okay. So then we see about when we see about each and every quadrant, let's see the examples. Um, so if you look at it's a easy understanding for the east quadrant for the whenever the point location of A. So the first case, the point A is above HP and in front of VP. So the point A is above HP is looked at as A dash for the front view. And the same case as the top view is looked at A in a HP plane, that is a horizontal plane. It's a pictorial representation of your understanding. That is a pictorial means is called it as a three-dimensional viewing of the object. So it is a for understanding is a, we have to show that the diagram here. So the for the next case, the point A is above HP and VP. So in VP means the is called it as the point is located at the reference plane, or on VP is also meaning also on the point on the reference plane. So if you look at a point A is located at the first quadrant, we seeing at the front view of the point A is located as a dash is a particular height. The similarly in VB means the top view is looked at as a point A is lying on the XYY. So the third case, the point A in HP and in front of VP. So what is the meaning of these kind of cases? The point is lying on A. Whenever you're looking at A, there is a point A is moving it towards on the A dash is lying on the XY, and the A is located point is lying on HP plane. That is a from viewing of the top view. So this is the orthographic representation of the above all the cases. So this is the two-dimensional, this is the three-dimensional. So for understanding, we see the three-dimensional diagram. Whenever you're solving the problems, the two-dimensional is more than enough for to solve this problem. So for first case, we is discussing the point A is above HP and in front of VP. So whenever you're solving these kind of cases, they are give the dimension value in form of mm. So first of all, you convert in a centimeter, that you have to mention the diagram in value, so that you have to write in all dimension or in in your drawing sheet and above the title box. So for locating the A dash is above HP and the A is in front of VP means it is a meaning is called as A is below the HP and the A dash is above the HP. That is the meaning for the first case of the pictorial representation. So what is the second case of these conditions? The point A above HP and in VP. So what is the meaning that the above means is the A dash is located in above HP, that is XY, and A is located at a infant, that is a infant, not here the in VP. So that angular point is lying on XY plane. So what is the similar cases we discussing? A dash is lying on that is a XY and A is lying on HP plane. Okay, now so that this case is very understanding for the above pictorial diagram for these cases. Let's see the next slide. So whenever the first solve a problem, the first quadrant, if the point is above HP and in front of VP, then it's situated in the first quadrant. we are see the some pictorial representation orthographical diagram, but here I have to mention the dimension of the given diagram. Let's see. For example, whenever you are locating the point A is above HP and in front of VP, that is above value is given a problem is 30 mm and in front of value is a problem is 25 mm. So general observation of these kind of cases, general observation when the HP is rotating in a 90 degree, that is a primary factor, 90 degree in a clockwise direction, then HP is a top view will move the below XY line. The front view of the A dash will above the XY line is rising while the top view of the A will be below the XY line. That is a for understanding for the two-dimensional diagram. The vertical distance from the HP will be visible in front view while horizontal distance from the VP is visible in top view. So the left side image is shown as the pictorial diagram and the right side image is shown as a orthographic diagram. The pictorial already I said this, that is a three-dimensional. The orthographic is the meaning is called as two-dimensional. Okay, this is a basic understanding how to the solve the problem the based on the projection of points in real-time example. So if I take as a 3 mm means the meaning is called as 3 centimeter. So you have to draw the XY line and place the horizontal, there is a scale value, you have to locate the 3 centimeter, just you have to point it out. Then the same value, that is a 25, the below the HP, that is the meaning of 2.5, you locate the point A. So they are similar problem we have to see in the next classes for the each quarter. That is second quarter, third quarter, and fourth quarter. Thank you.